Evening, everyone, and thanks for joining me for tonight's Facebook live stream for some more Drayton training. I hope you've had a good day and a good week. As per the promo that went out yesterday, tonight is going to be all about zoning. So I'm going to be taking you through pretty much all of our product range, really, because everything, when you think about controls, really surrounds zoning and managing different zones on the heating system, so that essentially, if you want your central heating on, you're not heating up your hot water unnecessarily or other zones unnecessarily. So really, everything surrounding controls really does come down to zoning. And with that in mind, it's a way of really being able to drive your efficiency. So what I'm going to show you tonight is how you do, obviously, your basic zoning, where real mechanical stuff where we're using motorized valves and things, but then also how you can sort of finesse a system by just changing the controls at the head of it. So moving away from just a standard programmer where you've got on and off to maybe something with load compensation. So that's really the sort of plan for tonight. So it's going to build up as we go through, and then right at the end I'll be showing you wiser how we can multi-zone and have individual room control. So if I start off by sharing this with you. So this is really going to be surrounding our control packs. This is really the best way of buying our kit. You can obviously buy the stuff as individuals, if you want to buy a motorized valve or a cylinder stat or whatever. But if you're going to go in and actually fit for a new job, it's most cost effective to buy our controls in a control pack. And so on our website, it's segregated out so you can choose what you want, whether you want 𝗵𝗀 or twin zone. Now, 𝗵𝗀 is what you would normally know as a Y-plan system. So you're going to have a mid-position valve. We call it 𝗵𝗀, but it's a Y-plan. And twin zone is your S-plan, so where you've got two separate two-port valves. And we've also got some others suitable for a combi, unvented, and also a frost stat. So if we just have a quick look at the twin zone, I'm not going to remember these part numbers, and I wouldn't expect you either to. But this is you'll find that probably you use one. When I was sort of installing this stuff, there was the 𝗵𝗲_𝘁𝗶𝗴 was sort of my go-to. That the 68 and the 86, those were the two. And really the different part numbers just changes what sort of programming you get, whether you get, say, like a 24-hour or a 7-day. But ultimately, a twin zone control pack is going to have two-port valves in either 28 or 22, depending on which pack you go for. You're going to have something to control the temperature of your cylinder, something to control the temperature of your room, and something to control timings for both of them, plus a wiring center to wire it all up into. And my preference was always to have the LWC1 because it's bigger. And if you want, particularly if you're doing twin zone and you want to maybe down the line add another zone to it, another zone valve, another set of time and temperature controls, the LWC1 is by far the better wiring center to do that. We also do the LWC3, which is smaller if space is a premium. So once we've sort of chosen that, you can sort of get it in there. And the thing like the room stats, it's normally like an RTS1 with an LP, and your cylinder stat's always going to be our HTS3. But that's all. They're all fairly you sort of know them. They're all fairly simple controls. What I wanted to do, if I just come back into the room, I want to just go through our range of motorized valves that you get in there. So the two I've got to show you tonight are a two-port valve, which is the ZA5. So this is what you would get on a two-port body. So this here is a 22 mil, but we also do it in 28. And you can also get them in Imperials as well, which will accept male iron, but you're buying those as separate. So you would buy the body separate to the actuator. But the great thing about this, and obviously you can see it from this, is that they're detachable by just pressing in the button. So when you're installing these, you pop your top off. You don't have to worry about the actuator being on, and then you can plumb away. Now with these, they are stamped underneath. You can see the ports. You've got A and B, and it's important that you get them the right way around. So you flow in on A and out of B. Now, if you do it the other way, it means that you tend to get a bit of hammering when the valve closes, because the idea is that with your flow going in on A and out on B, when the spring is pulling it back, you've got the system pressure there, which is going to sort of cushion it as it comes back onto the seat. If you plumb it the other way, you've got the system pressure sort of pushing it onto the seat, so it tends to bounce on the seat and you get a little bit of hammer. So thing to remember is that in on A and out on B. Now, when you pop the actuator on top, you've also got A and B on the side of there to show you whether it's in the open or closed position. Now, these are diametrically opposed to what the stampings are on the bottom of the body. So port A here, this is actually this port here. So when you're looking at the actuator, they're opposite to the way the actuator shows it. So port A there, if we tip it upside down, you can see that port A is diametrically opposed to that. So you can't look at the actuator and think it's the one right below it. If you do, you'll plumb it the wrong way and it's likely to be noisy. Now you can see this one here, the little indicator is actually in the mid position. Now that's how these are supplied. And if we look at the lever at the end, you can see it's in flush to the body. Now this is the vent and fill position. So when you're fitting these, obviously you don't want them to be closed because when you're filling the system, you don't want to be trapping air or preventing part of the system from filling. So it comes in the vent and fill position. Now, once you're ready to commission it, you can either move the lever over and pull it out, and you'll see that it now moves back to the A position. So under normal circumstances, that lever is hanging out of the body like that. Or if the first time you power it up, you'll move it over to position B. B is the open position, and that will unlatch this lever anyway. And then when you de-energize or you stop the core for heat for that particular zone, it will go back to the A position. So really useful to be able to see what's going on. And when you're installing this, obviously you want to put this in a position where you're able to see it easily. You don't really want this up against a wall, because this is invaluable when you're trying to fault find. And for me, if there's a fault going down on a system, the very first thing that I'm asking is, what is the motorized valve doing? What position is it in? Because that will tell you a lot about what's going on. Now, with these being a detachable actuator, it means that if you've got, obviously, if you need to replace this, it's easy. You don't have to drain down. But also, it's, again, fault finding. If you pull the actuator off and then suddenly it moves, you know that it's being held off by the body. Now, the other thing with this, all of our actuators are interchangeable with all of our bodies. So this here is a mid-position actuator. You can see it looks pretty much the same. This one's a little bit used, I would say. But this has got your water, mid, and heating. So this is always going to be supplied on a 3-port body. It's nonsensical to put it on a 2-port because if it sits in the mid position, you've just got a 2-port that's slightly less open than it would be. So this will fit on a 3-port body. You'll feed up the leg of the T from your boiler, and then you'll divert through ports A and B to central heating and hot water. So obviously the essence of this is that you can have either or both, and this is what would go onto a Y-plan system. But like I say, they're all interchangeable, so this will fit onto a 2-port body in the same way that the 2-port actuator, the ZA5, which is a 5-wire actuator, if you put that onto a 3-port body, you've now got a diverter valve, so you've got an either-or system. We also do the ZA6, and that tends to come with the 28mm bodies. That's got an extra wire on it, an extra white wire, which is just a normally closed position. So what you can do with that is, if you want the valve as it is now, if we energize the valve open, so we move it from A to B, we make the little contact inside, and that sends the signal off to fire the boiler. With the ZA6, you've got the extra wire, which is the normally closed, so you can have it so that when the valve is in the closed position, it does something. When it's in the open position, it does something. But as they're interchangeable, if you've got a ZA6 on a system that's failed and you're not using that white wire, you can easily replace it with a ZA5. So as long as that white wire is just going into a dead terminal in the wiring center, then you can easily replace it with a ZA5. And likewise, if you are going to fit a ZA6, and you obviously you're not going to use the white wire, perhaps if it's just a standard S-plan system, then just make sure it goes into a dead terminal in the wiring center. Don't just snip it off, because it potentially could go live, depending on how you wire the orange and the grey. It potentially could go live when the valve is in the closed position. So just make sure that goes to a dead terminal. So that's really the oldest way that we would do zoning. So it's quite common if you wanted a hotel to, have individual room control for every single room that they want to control. You're going to have a zone valve, which is permitting or restricting flow into that particular room. And what will be controlling that is time and temperature. So our rationale for doing this now is to be compliant with the building regs, so Part L of the building regs, which says that you need to have time and temperature control and an interlock to the boiler, meaning that when there isn't any core for heat, the boiler can be turned off. So you're going to have something doing time and something doing temperature, which is going to be driving that valve open and closed. And then the little end switch inside, which is why you've got the 5 wires there, the orange and the grey, that's what's going to control the boiler, so that when the valve is in the closed position, it will kick the boiler out. So those will fulfill your time and temperature requirement for Part L of building regs. Obviously now, if we wanted to subdivide the house, we're probably going to look at a solution more like 𝗿𝗀𝗁𝗲, which again, you've got that interlock, but because you can use the smart radiator thermostats, you're able to zone without cutting any pipes. But the motorized valves are still the core of the system, and if you're doing a big system, I would still look towards having a standard architecture where you're zoning the pipe work. If it's a new build, I would still be putting in your separate loops. I wouldn't just be putting a big loop in and then resorting to 𝗿𝗀𝗁𝗲. The best system is one where if you've got sort of separate areas that logically can be zoned, you would pipe them and control them with a zone valve, and then you would use 𝗿𝗁𝗲 to subdivide that particular zone rather than sending hot water all the way around all of the system. You'd still only be sending it on the respective zone, just to try and drive your efficiency a little bit better. Right, with that in mind, so we've built up a system, say, where we are using we're using zone valves. What we could do then is give the customer some improved control by upgrading the programmer to 𝗿𝗁𝗲 or to the new Digistat. Now this here, if you haven't seen it already, this is the receiver for the RF902. So this is a twin channel receiver that you can use for heating and hot water. It comes with the RF90T, which is the room stat, and you can use this to zone either a combi boiler, so you can assign 2 separate receivers to it, or you can have it whereby you control heating and hot water all off of the room stat. But the important thing with this is it uses the same backplate as, say, an 𝗵𝗲_722 or a 241, or indeed any of the 2-channel range of our programmers. So if you want to give the customer some instant capability to improve their efficiency and essentially give them load compensation, you can take the room stat off of take the programmer off the wall, so take the 𝗵𝗲 off the wall and install this on the backplate. The only bit of wiring you're going to need to do is, if they had a wired room stat, which you would hope so, you'll just need to link that out in the wiring center. But this is a really good way of being able to give them some sort of smart control. Now, it's important that we don't confuse smart with connected. So 𝗿𝗁𝗲 is a smart connected control in so much as it has an internet connection. But this is smart control in so much as it's load compensating. So when you set this up, you choose your fuel type, you choose your oil, gas, electric, or heat pump, and that will then change the modulation. So as standard is gas, that's 6 cycles per hour. So you can expect the boiler to fire once every 10 minutes, provided there's demand. The minimum amount of time it can stay on for is 1 minute. Obviously, the maximum would be 10 minutes. But what you will find is it will work out through, it builds a thermal profile of the area where the thermostat is, and it will work out how long in each 10-minute bank it needs to run in order to maintain set point. So when it first, if it's trying to get the temperature up in the house, then it will be on for maybe 10 minutes in every 10, and then as it approaches set point, it will start to reduce down, and to the point where it might be just 1 minute in every 10. So again, when you're fitting this for a customer, if you're taking out, say, an 𝗵𝗲 or a control which is very much just on off, it's still attached to time. You can still put timers, it will still have a timer attached to it, but it's very much on until the time period and then off. You may have to just explain to the customer that the control theory has changed, and they may see that their boiler fires more often than it does, or it was. But the important thing to look out for is maintaining temperature. So it doesn't matter if the boiler is firing more than it was before. The important thing is to make sure that it's maintaining set point. And obviously this will give you more accuracy than if you're using an RTS1, because the hysteresis on these is 0.5. So you're never going to be more or less than 0.5 away from set point. So a real nice way of being able to give the customer smart control without having to get involved with a load of wiring. And similarly, this shares the same backplate as a 𝗿𝗀𝘁𝗀𝗃 Kit 2. So if you want to give the customer smart connected control, we're not disrupting the system. We're still using the motorized valves on the system. We're still using the cylinder stat. So we're not disrupting the system in any way. All we're doing is we're taking the head of the system, which is like the power supply, the existing programmer, off, and we're replacing that with the 𝗿𝗀𝘁𝗀𝗃 Kit 2 or the RF902. And wiring's exactly the same. The only thing is, remember to link out your room stat. Now, as a workaround, while you're testing this, you can just stick the room stat, the existing wired room stat, that is, you can just stick it up to maximum, because unless it was a summer like last year, you're never going to exceed 30 degrees normally. So you can do that as a workaround. You can link it out permanently in the thermostat if you want. But the more elegant solution is to do it in the wiring center, because that then gives you the opportunity to remove the ode control off of the wall. But if the customer's not bothered by it, or it's sometimes the wiring centers there, they may not be a formalized wiring center. It might just be a load of chock blocks. So if the customer's happy for the ode control to stay put, then you can link it out in there. But the important thing is we need to link together those two switch wires, because we don't want two thermostats, whether it's a 𝗿𝗀𝘁𝗀𝗃 stat or whether it's the thermostat that goes with the RF902. We don't want them fighting a wired stat, which is going to interrupt the line between the thermostat or the receiver of the thermostat and the motorized valve that it's controlling. So next thing that I want to talk about, so that's really your sort of your zoning using electronic controls and having motorized valves. What we then want to get into is individual room control. And by having individual room control, you can make savings of up to 19%. Now, that's not immediately 𝗿𝗀𝘁𝗀𝗃 that we're talking about. We are talking about having TRVs in every room, except one maybe for if it's wherever the room stat is. So this is where, if you've got a fixed room stat in, say, your hallway, then the old advice was always that you would just fit a lock shield either end of the radiator. You wouldn't have a TRV body. What I would say now, particularly with products like 𝗿𝗀𝘁𝗀𝗃, you don't really want to have a radiator that doesn't have a TRV body on it. Even if you don't put a thermostatic head on, fit the TRV body and just put either a manual wheel head or leave the decorator cap on, or you can get chrome caps, which are a little bit more decorative. But if you're plumbing up a system from scratch, I wouldn't be now, even if you intend to have a thermostat that's sort of fixed to the wall in a particular room, I would still put a TRV body on that radiator, because if you then want to upgrade to 𝗿𝗀𝘁𝗀𝗃 in the future, you want to be able to get a 𝗿𝗀𝘁𝗀𝗃 head on that radiator. So a quick look at an overview of our TRV. So this is the RT212. So this is our entry level TRV. Now it may be entry level, but you can see it's got the key mark on it, which means that it is EN 215 accredited. It's got which all of ours are. So it doesn't matter whether you go for the entry level, whether you go for the 414 or the TRV4, they're all EN 215 compliant. This has got a liquid sensor. Now it used to be wax, but it's now got a liquid sensing element in there, which is much more reactive, and it actually shares the same bezel as the 414. So you get things like you're able to range limit it, so you can see underneath the vents under there, as well as being vents to allow air in. There's also a pin. There's also a pin there that you're able to range limit it. So if you're fitting this in a communal hallway and you don't want people to be turning it up too high, you can pin it so that it only goes up to, say, position 3 or whatever setting you want. Similarly, if they're going into care homes and you want to make sure that you don't set the temperature too low, you can also pin it the other way. So if you start at maximum and then pin it, it means that it won't go below. You can also get extra pins, and if you put one each side of the setting, it's actually locked into position. So, and that's exactly the same principle that you get with the RT414. So you could say, well, what's the difference between the two? Because they're both liquid sensors now, and they're both EN 215 compliant. So the difference is the bodies that they come with. So the 212, which is our entry level, comes with what we call our fixed flow rate body. So it's very much a contractor's body. There's nothing that you can replace in the top there. There's no replaceable gland seals. There's no way that you can balance on this. And when you look inside, you can see that it's essentially full flow. So the aperture that goes into the radiator is wide open. So these can be a little bit more tricky to balance with because it's more critical on what you do at the lock shield end, because you don't have that sort of built-in resistance that you get with the EB body, which is the one that comes with the TRV4. So this comes with the RT414 and the TRV4, but when you look at a side by side, so if you're using super low flow temperatures, you're probably better off with the 212 body if you need to get a lot of flow through the radiator, because the EB body comes with built-in resistance by just having that, I think it's something like a 6mm hole on the output. And when you look at the bottoms, the inputs are pretty much the same. If I can work out how to get it in shot. There we go. Pretty much the same. So fixed flow rate body comes with the 212. The EB body is the one that you can actually do the balancing on, and you can replace the gland seal. So with this one, the gland seal comes out, so you can replace it. Now, the idea of that is that obviously over time, the pin is going to be moving up and down, and it's going to be wearing the rubber seal on the gland seal. Now, this is a secondary seal, so you've got the main seal in the body there. This is just if anything gets up past the pin, it's held in that chamber, and the gland seal just stops that then coming out. So you can replace these on a live system because you're not interfering with the main seal. I would probably just put a rag underneath so that if there is anything in there, you may get the odd drip, but it's certainly not going to be under any sort of pressure. So you can replace the gland seal on a live system, and to do that you would use this, which is our pre-setting tool. So you would use that end that fits into the gland seal and just screw it. Once you've taken the old one out, screw the new one down until it's flush with the top. Now, this key also has other features. So with this body, you can actually balance. Now, remember, the whole principle of balancing is that we're trying to increase the resistance of a particular radiator in order to make sure that there is no sort of short circuit path through a radiator from the flow and return back to the boiler. So you want to be keeping your return temperature below dew point, so below 54 degrees, and that keeps your boiler in condensing mode. So the way we do that is, generally speaking, the radiators that are closer to the boiler will have more resistance than the ones further away. So with the EB body, now I've just disassembled this one. So this is the insert that goes into the EB body. So there's your output port. And what happens is you align that with the segments around the bottom. So the big square there, the one I'm showing now, that's position 6. So that's essentially the body wide open. And then you've got positions 1, 2, 3, 4, 5, progressively getting bigger as around the bottom of that insert. So when that insert sits inside, you can see, if I can get this in shot, that as I turn it, you can see that we've got different size apertures. Now, the way we do this is obviously you can't afford to take the clamp ring there completely out, because if you do, there's nothing holding the insert in. So the way that you do the balancing with these is you use the tool, you insert it, and you can turn it around about 180 degrees. Now, as long as that clamp ring was in and tight before you did it, if you turn it 180 degrees, it means that it takes the load off of the insert, so it allows the insert to turn, and so you can turn it to one of those 6 positions, but it means that it's not going to risk blowing out. So when you're turning this insert, you want to be turning it in a clockwise direction, so that if by turning the insert it picks up the clamp ring, it's only ever going to tighten it. Now, if you go past your position, so say if you're aiming for position number 3. You're going to start off at 6. You're going to go 1, 2, 3. If you go past that, just keep turning in a clockwise direction, 4, 5, 6, 1, 2, and then stop at 3. And obviously, because you've got those positions, you've got to actually land on a position. If you try and go for a half position, you won't get any flow at all through the body. So that's how you balance with these. So if you're using these, you're going to do the balancing, choose your position 1 to 6. The instructions in the box tell you what flow rate you get for that. Your lock shield on the other end is going to be left wide open. Once you put the TRV on, the system is balanced. If somebody wants to remove the radiator for decorating, they'll take the TRV head off, they'll put a decorator cap on here, wind the lock shield all the way down, radiator off. When it goes back on, all they've got to do is wide open with the lock shield, decorator cap off, and the sensing head back on, and they haven't lost balance. So it's a really good idea if you're using these to do the balancing on these. With the 212 body, the only way you do your balancing is with your lock shield. So that's a key reason why it's, if the customer's considering a 212, have a look at the RT414 because it gets you the EB body. It also now gets you, or there is an option to have it with this, which is our latest body, which is the auto balancing body. Now this one, whereas the other one is sort of fixed balancing, so you pick an aperture size and that is fixed. With these, the aperture is always varying. So as temperature and pressure rises in the system, the aperture will change to make sure that you've got a fixed flow rate into the radiator. So if you know what the output of the radiator is on the box that these come with, it tells you what setting you need to set the top to. And again, you can use the tool, or indeed an 11mm spanner will allow you to turn that insert. So you can go anything from 10 liters per hour to 150 liters per hour. The box will tell you if you're retrofitting these to radiators that you don't know what the output is. There is an online calculator that you put the details in. So you measure the size of the radiator, you choose the radiator type, which is essentially based on number of panels and number of fins on the back. And you then will choose what your delta T is. Now, the delta T that we're talking about is not the difference between the room temperature. It is the difference between the flow and the return. So we give you 3 options. We give you 10, 15, and 20 degrees. Industry standard is 20 degrees. But the reason we give you the others is some of your designer radiators will give you different performance data depending on what temperature, or difference in temperature between the flow and return. So you can choose what you want. Your cheaper radiators tend to not give you that detail, in which case you would be choosing delta T of 20. Once it tells you what it is, you turn the insert on this one until you get the desired flow rate. The other end, the lock shield stays wide open. You don't need to do anything with it. So you're always in balance. Now, with these bodies, in fact, with all of our bodies, they're all compatible with all the different heads. So these are available in packs with the RT414 and the TRV4. But if you happen to need to put a head on it and all you've got is a 212, it will work. And also, 𝗿𝗿𝘁𝗲 will also work with these. So onto the subject of 𝗿𝗿𝘁𝗲 and what we would be if this is really where we start getting into the individual room control. Now, I'm sure you've all seen. Let me have a quick see if I can whiz through this slide deck and just give you some of the stats on 𝗿𝗿𝘁𝗲. So this is really the sort of architecture of how 𝗿𝗿𝘁𝗲 works. And one of the key selling points for the customers is, whilst you can have all these different devices that are controlling individual radiators, they're very much working on their own network. So you can see here that whilst we've got all the integrations with Google and the Panasonic cloud now, if you've got a Panasonic Aquaria heat pump, you can actually have the heat pump data piped into your app through the cloud linkage. The reality is that the devices, the smart TRVs, the smart room stats, the smart plugs, they all sit on their own network, so they're all communicating. So if you lose all of that other infrastructure, your Wi-Fi or any of the cloud services, the system is still going to carry on following its schedules, and you're still going to have control with the in-home devices. And if all you've lost is a cloud service, if your home Wi-Fi is still up and you're at home using your phone, you shouldn't notice any difference with being able to control your WiSER system. But the smart radiator thermostats really do give you the capability to individually subdivide the house. You've got a maximum of 16 zones, and actually that will bring me on to the next slide, which is the system capability. So this is really where WiSER's system capability is here. So 16 zones. Total number of devices is 64, but one of those is the hub. So in reality, it's 63 other devices. And then that breaks down into 16 room thermostats. So you can't have more than one smart room thermostat per zone because it doesn't make sense to have more than one per zone. But you can have multiple smart radiator thermostats per zone because it's highly likely that you might have a room that's got 2 radiators. Or if you've got open plan living, it may be that you have 4 radiators in an airspace. So rather than having them all individually controlled, you'd add all 4 to one of your 16 zones. You might then want to add a smart room thermostat to that in order to centralize the sensing. On top of that, you've got WiSER underfloor heating controllers. So if I just pop back to that one, remember we've got the solution for wet underfloor heating, where you can have up to 6 zones of wet underfloor heating. So each one of those zones could have a WiSER smart room thermostat assigned to it. And we've now also got the electrical heat switch if you want to control heating loads up to 16 amps. Now, I'm coming to the end of this now, so this is just really a heads up on if you've got any questions, stick them in the comments because I've only really got one more thing to talk to you about, and that's really a look to the future on what's coming up this year. So obviously, this is very much sort of the old way of zoning, and with technologies like OpenTherm now. We're looking more towards priority domestic hot water systems, where instead of having a mid-position valve or a valve that opens to feed a cylinder, which is, in essence, is a very short loop. So this idea of trying to keep your return temperature below dew point and keep your boiler in condensing mode doesn't really stack up when you're if you choose just to heat a cylinder. Because it's got the indirect coil inside is very short, so it's highly likely that before the cylinder or the thermal mass of water is up to temperature, your return temperature back to the boiler is going to be above 54 degrees. So you're going to be running your boiler quite inefficiently. So there is a move towards priority domestic hot water where you use normally open zone valves. Now we don't currently have a normally open zone valve in our lineup. But it is coming. It's something that's on the table, and we're looking at, because if you use the normally open zone valve with OpenTherm, and again later in the year, WiSER's implementation of OpenTherm is going to be really improved. So it's going to be a much better solution if you want to connect to an OpenTherm boiler. But OpenTherm with priority domestic hot water really is the way forward, and that's obviously where we're going to go, where the industry is going to go. But at the moment, our control packs very much sit with the sort of more traditional, where you're doing S plan and Y plan. But it's certainly something. Has anybody got a pound for the meter? That'd be nice as well, because I think I'm going to run out of lights. But yeah, that's sort of where it's going. So last thing for me is any questions. I don't see anything that's come in from tonight. I've got a question that did come in overnight, which is talking about WiSER underfloor heating. So let me whiz back to this slide. WiSER underfloor heating using what happened. So the question actually is, that might be sensible to read the question. So the question is, I'm aware that you can control 6 separate zones of underfloor heating with WiSER, but what happens if I've got a zone which has got more than 4 separate loops? So as you can see from the screen here, we've got 6 separate zones, but we've actually got the capability to control up to 14 thermal actuators. Now they need to be 230-volt thermal actuators, and generally they're about 2 watts, I think. But there's no requirement to use ours. We do them. We do the TS Ultra and the TS Ultra Plus. But as long as your existing thermal actuators comply with 230 volts and more or less 2 watts, I think, you'll be fine. But the question is, what happens if I've got, say, 5 loops? Because obviously zone 1 there will handle 4, zone 2 will handle 4, 3 and 4 will handle 2, and then 5 and 6 are singles. Well, what you can actually do is when you assign a room stat to the system, it will ask you what it is that you want to control. So it will ask you if you want to control the radiators or underfloor heating. Obviously, if you choose radiators, it's going to fire the relay in the 𝗲𝘀𝗀𝗃 hub. But if you choose underfloor heating, it will then give you your list of 6 available channels. But what you can do when you're going through that list is you can choose to control more than one channel with any one room stat. So here it's 1 for 1. But what we could do is we could have just one room stat, but we could assign it to, say, channel 1, 2, and 3. So if we wanted to control, say, 5, 6, 7 different loops of underfloor heating with the one room stat, we can do that, and that's just essentially by the way you assign it in the 𝗲𝘀𝗀𝗃 app when you're going through the setup. So you don't have to do 1 for 1 like you do here. You can choose to have one room thermostat controlling multiple zones. So it could be zone 1 and 2, and then you've got up to 8 thermal actuators that you're able to control with the one room stat. Right, last call for any questions. Not seeing anything at the moment, but I'm probably down to my last minute. The thing I'm going to talk to you now about is the priority shop is now open. So I saw some questions come in. When is it going to reopen? Well, it is now reopened. It has now reopened. So you can get on there, and there's some good deals going down on 𝗲𝘀𝗀𝗃 and auto balancing bodies. So get over to the 9 Degree Network and have a look at the priority shop. There is also the know-how modules on there. So if you go into the academy, there are some know-how modules. They're all being updated, and I'm going through a process of reviewing those this year. So there's going to be new modules that go on. There's going to be one that aligns to installation. So again, in detail, how you would wire up our control packs. There's going to be a fault finding module. There's going to be one where I tear apart our motorized valves, so you can have a good look at what the internals look like in the motorized valves, as well as refreshing some of the 𝗲𝘀𝗀𝗃 stuff as more questions have come in about underfloor heating and electrical heat switch. So the bolt-on modules there are going to also be revised, along with some of the animations of the early ones. So when you do the early modules of 𝗲𝘀𝗀𝗃, it's the animations. The commissioning journeys are also going to be updated. So I don't see any questions. So thanks for joining me tonight, guys. I'll be back in a month. So it's the training for me. If you want to stick it in your diaries, it's going to be the 2nd Thursday of every month. So promo will go out the day before about what the topic's going to be. If you've got any questions, you can stick them in the comments. This will also find its way up onto YouTube. So even when it's not live, if you've got any comments or anything about what you've seen, or indeed anything that you want to see in future videos, any topics you want me to cover, stick it on any of the videos on any of our platforms, and I'll do my best to accommodate. Thanks for joining me, guys. Have a good rest of the week, and I'll catch you soon.